Hey, what's up folks? How's it going? This is Waj. Hope you guys are all doing well. And in this video, we're going to be building probably one of the most powerful PCs we've created thus far using the Intel Core i7-6800K processor and the NVIDIA GTX 1080 GPU. What's really interesting over here is we're going to be doing a full CPU and GPU hardline water cooling loop using PETG hard tubing. So we're going to be going through kind of the step-by-step process of how we created this PC, and then we're going to be doing a part 2 of this video where we'll talk about some of the overclocking results and obviously some of the performance tests. So if you're interested in creating a PC with all the current generation high-end componentry that's out there, well, we're going to find out and see how this thing turns out. Now, in terms of our parts list, as we mentioned before, we're going to be using the Intel Core i7-6800K. This is an unlocked 6-core CPU that has 12 threads. We actually have a dedicated review up on the channel. You can click the screen to watch that video right now, but it's based off the Broadwell E architecture. It's actually the cheapest CPU in that lineup, but it's going to give you excellent multi-thread and single-thread gaming performance, as well as be pretty good for productivity-based applications such as photo and video editing. Now, in terms of our graphics card, we're going to be using a single GTX 1080. This is the MSI Aero version. It has a nice factory overclock, but we're going to be pushing it a little bit further since we're going to be doing some water cooling. Next, in terms of our motherboard, we're going to be using the X99 Designer from Gigabyte. This is an excellent motherboard that has pretty much all of the features that you would want in a current generation X99 boards, especially if you're going to be using M.2 drives and fast solid state memory. You have plenty of space for lots and lots of DDR4 memory, and this has a built-in RGB lighting as well. Check out the full review for more information. In terms of our RAM, we're going to be using a DDR4 memory from Corsair, the LPX 2800 megahertz version, which is a little bit slower for DDR4 spec, but perfectly adequate for our needs. You can see that we have 4 modules with a capacity of 16 gigabytes each, giving us a total of 64 gigs. In terms of our storage solution, we're going to be using a combination of M.2 and a standard SSD. So we're using the 950 512 gigabyte PCI Express NVMe M.2 drive. This has a absolutely amazing read and write performance, and we're going to be using it in combination with a 1 terabyte Evo 850 drive from Samsung as well. Now, in terms of our PSU, we're going to be using the RaidMax Vampire 1000 watt 80 plus gold certified half modular PSU. This is pretty darn excellent for the price that you get, and 1000 watts is going to be more than enough power for even to throw another GTX 1080 down the road. Now, what's going to make everything really kind of special is the chassis that we're using, the Thermaltake Core P5, which is kind of an open airframe style case, very unique looking. You can also wall mount it. You definitely want to use a case like this if you're going to show off your nice components and if you're going to be doing some hard tube water cooling like what we're going to do. Now, moving on, let's talk about the components that we're going to be using to water cool our actual PC. Firstly, when it comes to the CPU block, we're going to be using the Thermaltake Pacific W2 copper block, very competitively priced at around $75, and it also has LED lighting that you can modify the shades to a couple of different colors. Very easy to work with. Thermaltake makes excellent products and is going to match well with our case. Now, in terms of our GPU block, we're going to be employing the XSPC Razer GTX 1080 block. It has a CNC machined copper base plate. The mounting points for this block will also fit most 1080s and 1070s, which is excellent. All you have to really do to install it is simply replace the stock cooler with the water block using the exact same screws and mounting points. You want to make sure that you put in some fresh thermal compound and replace the seals and heat spreaders. The whole process is fairly simple and straightforward, laid out in the manual. Should take you less than 10 minutes to swap out the factory cooler. Now, the specific tubes that we're going to be using is from Thermaltake. It's the PETG hard tubing. It's 16 millimeters OD with an inner diameter of 12 millimeters. When it comes to hard tubing, you either have the choice of PETG or a standard acrylic. In most cases, people prefer PETG because it's a little bit more stronger and more resilient, and I find it's easier easier to bend and work with as well. Now, in terms of fittings, we're going to keep things as simple as possible since we're going to be doing a lot of bending anyways. So I'm going to be using a 16mm OD to standard G1/4" thread that's going to mount onto all of our water blocks, radiators, and pump. These fittings come from Bits Power, and the compression fittings, when you are looking at hardline tubing, you essentially want to focus on the outer diameter, which is 16mm in our case. So when you are buying the fittings, you want to make sure that they have an outer diameter parameter that matches the size of the specific hard tubing you're going to be using. Moving forward, we're going to be using a pump and reservoir combo from, again, Thermaltake. We're using the Pacific DIY PR22-D5. This has a variable speed pump, which is definitely very handy. And as you can see, a built-in reservoir at the top with a nice fill port. So installation should be pretty simple and straightforward. This is a pump specifically designed for novice and beginners. Now, since our case can support a 480mm radiator, we're going to be using just that, specifically the XSPC EX480. And with its copper and brass core and large area for heat dissipation, this is going to fit nicely with our CPU and GPU water cooling configuration. Plus, we're going to pair it with 120mm Thermaltake ring fans. These are RGB LED backlit fans that will give you thousands upon thousands of different color combination. And these fans come with an integrated controller, allowing you to change the color parameters as well as the fan speed manually on the fly. Lastly, I'm going to be using some Pacific DIY coolant from Thermaltake. You definitely don't want to use something like tap water, which contain bacteria and foreign chemical agents that will probably degrade your internal componentry built into the loop. Now, besides that, you are going to need some essential tools to actually set up your water cooling loop. Firstly, you're going to need a pipe cutter. Something like this, a circular rotating pipe cutter, works really well. It's fairly inexpensive, and this is typically designed for plumbing application, but it gives a nice clean cut both in the inner and outer side of the tube. You also should get some sandpaper just to smooth out any rough edges so you don't cut the inner gaskets in your fittings and develop a leak. You're going to need a heat gun. You can use a hair dryer, but a heat gun will control your temperatures a little bit more accurately. And lastly, you're going to need a silicone tube insert, which will maintain the inner circular shape of your tube while you're heating up and bending your PETG tubing. Now, the grand total for all of our PC components and the water cooling setup is just under $3,500. Now, that's definitely a decent amount of money, and just for the water cooling supplies alone is around the $650 mark. So water cooling is definitely not for the budget PC builder in mind. So if you're going to be doing a full water cooling loop, whether that be soft or hard tubing, definitely be mindful for all the components that you're going to need to make your system happen. Now, one of the things that I wanted to do for the preparation of building this PC is I actually wanted to do a mock-up of what my hard tubing lines will look like in terms of the specific bends that I'll have to make and just how everything will fit together. And a great application for that is SketchUp. You can kind of 3D model any type of PC, really. There's a great library of different 3D models that users have uploaded if you don't want to create anything from scratch. Here is essentially what the final PC should look like, and this will give me some sort of rough guidance of how my tube runs should look like. So the first thing that we're going to tackle is the motherboard assembly. So we're going to install our CPU and then make sure that we're applying a little bit of thermal compound to that CPU so we have even heat dissipation as well as some sort of medium for the heat to transfer over to the water block. Water block installation is really simple and straightforward on a 2011 socket since the mounting threads are built in right into the PCB. So just go ahead and tighten everything up nicely and securely. Then we can take the pump power connection and connect it into the CPU fan connector. After that, go ahead and install your RAM. And when I was doing this, I didn't really read the manual properly, and it's not going to boot if you don't have the RAM in the correct slot. So just check with the manual to find out the exact configuration. Next, we're going to install our 480mm rad to our case. Since we're using the Thermaltake P5, there's plenty of different mounting points at the back of the case, so things are pretty simple and straightforward motherboard there. And the nice thing about using a 480mm radiator with this case is that we have a nice height continuity, so you have a radiator that starts from the bottom to the top of the case. Now right after that, we're going to install our pump/reservoir, and we're going to mount it vertically. You can also mount it horizontally, and it comes with these two mounting clips that will snap directly onto the reservoir, which makes assembly really simple and straightforward. And essentially you attach these two mounting clips to your case itself, and then the reservoir will clip directly onto those brackets. At the side of the clips, you'll find that there's a tensioning screw that will allow you to adjust the amount of tension that the clips are using to actually attach onto the reservoir. And the nice things with this system, if you want to remove the reservoir for installation purposes, things are pretty simple and straightforward to do so. Now, since we have the pump/reservoir in, we're going to install the motherboard onto the case, and we want to make sure that we're using the proper standoff screws that came with the case so we don't have any shorting issues. Once our motherboard is installed, we can now start installing our water cooling loop. So the first tube run that we're going to do is from the CPU water block to the radiator, and this is going to be a fairly long run, and essentially you just want to measure things out, and based on my particular design off my 3D model, I'm going to go by what specific measurements I need to do. But you can eyeball a couple of different things, but it's a good idea to get some sort of ref measurements. Once the tube is bent, it's fairly malleable, and obviously you can cut things directly to size. Once the tube is properly cut to size, you can then use the compression fittings to attach it to the CPU water block to the radiator. The next tube run is going to be from the radiator to the top of the reservoir, and this tube run is certainly going to be a lot shorter, and we're going to put a little bit of an angle onto it to basically make sure that we're not using any more tubing than we need to. By the way, as we mentioned before, cutting the tubes is pretty simple with the tube cutter, and it's relatively clean, but it still leaves a little bit of a sharp angle. So just make sure that you're sanding off any rough edges that might cut the inner gaskets of your fittings, because you do definitely have to put a lot of pressure into actually inserting the tube into the fitting portion. Now's a good opportunity to take our GPU that has the water block already installed and insert it directly into the PCI Express slot on our motherboard. I'm going to insert the GPU onto the third slot down to give us adequate room for our tubing. After that, we're going to install our PSU, so we have everything pretty much installed in terms of all of our PC components. And once that is done, here we encounter the hardest tube run from the GPU to the pump/reservoir. We're going to need to put in 4 90-degree bends on this tube run, so took a little bit of time to complete, and with a little bit of trial and error, I finally had a tube run that would work both functionally and aesthetically. The last tube that we're going to connect is obviously from our GPU to our CPU, and basically this is going to be the shortest run, and it's just going to have a slight 90-degree bend going from those two water blocks. Okay, so once we have all of our tubes connected, you want to check and double check all your connections and fittings to make sure everything is nicely, securely fit. You don't need to over tighten it, but you definitely want to make sure that all your tube fittings and tube ends have a nice secure fit where the gasket is making even and full contact with them, so no liquid is going to escape on either ends of the tubes. Once you're confident with that, it's time to now fill up the reservoir with our coolant, and we're going to be using this handy squeeze bottle that actually came with the Thermaltake coolant, so nice little plus feature there to make filling a little bit more simple and straightforward. And we have a fill port, as we mentioned, in the reservoir, so we don't need to route another tube or anything like that in order to fill our reservoir. And as you fill, you're going to see some liquid come into the bottom portion of your loop. And once your reservoir gets about 70 to 80% filled, we're going to stop right then and there. We're going to now need to power on our pump and nothing else, since we don't want to fry any of our components. So we're going to connect our power supply only to the power for the pump itself, which is a Molex connector, and we're going to need to jump the PSU so it can run without a connection to the motherboard. And to do that, you simply connect the top green and black wires of your 24-pin motherboard connector. You can use a paper clip, or I'm just using a twist tie and making contact with the green and black wires on the top portion of the 24-pin connector. Now, to turn on the power, you just simply cycle the power switch of your power supply, and you'll then eventually get the pump turned on, and then you want to pretty much turn it off. You want to make sure that there's always a little bit of liquid running inside the pump to avoid damaging the pump itself. So then you can feed more coolant into the reservoir and turn on the power, and you keep repeating the process until you have a sustainable water loop, and you can keep filling the reservoir to whatever your desired amount. Obviously, when the pump is turned off, the reservoir is going to naturally fill up, and when the pump is running, your water level should decrease. Now, obviously, during all this time, you want to make sure that you're leak testing everything, make sure that there's no water spewing out of your fittings to ensure that none of the seals have broken. And now you're going to pretty much get into the phase of bleeding your loop of any air bubbles. You want to make sure that you don't have any air in the liquid itself, because that will introduce thermal inconsistencies, which will decrease your overall cooling performance, which is definitely a no-no. Now, some tips for bleeding include adjusting the speed of your pump if you have a variable speed pump. The other thing you can do is tip the case in different directions and axes. You can turn the pump itself on and off. And lastly is going to be time. To fully bleed out the system can take a while depending upon how fancy your loop and how long it is. So definitely make sure that your fill port is fully open so all that excess air has somewhere to escape. And while that process is happening, we can actually use some paper towels to cover all of our fittings and run the system for at least 24 hours to make sure everything is nice and secure. And after 48 hours, the system looks all good. I didn't encounter any leaks whatsoever, and we would definitely find a leak if something occurred, because blue coolant on paper towel will definitely show through very clearly, and there's no evidence of that thus far, fingers crossed. And now we can basically complete our system. We're going to install our M.2 drive onto the motherboard, and we're going to install our SSD drive onto the case. We're going to also install our LED fans onto the radiator, so we actually have some air flow onto that radiator, and we can therefore dissipate that heat much more efficiently. Luckily, we do also have a fan controller which will control our color parameters as well as speed, so we can run the system fairly quiet. And I'm going to attach this fan controller with some Velcro onto the bottom portion of the case, so things are pretty accessible there. Lastly, you can install all of your main power connections for your motherboard, CPU, GPU, etc., as well as connect all of your front panel connectors and supply your SSD with data and power. But really on that, guys, that's really it. Generally speaking, I'm pretty happy with the overall configuration that we have over here. I have done some hardline and soft tubing PCs in the past before, but I'm nowhere near a professional, and it definitely takes a certain amount of practice to really make something look pretty. And although this looks okay, there's definitely some improvements that I would make later down the road, but it's definitely going to facilitate my needs for now. So what we're going to do is a second part of this video, and that video might be in the description down below by the time you're watching this, and we're going to basically take a look at the overclocking performance as well as the 4K gaming benchmarks. So if you're kind of interested to see how this thing actually performs, stay tuned for that video. But really, other than that, guys, that's really it. Check out the link in the description for all the little parts and all the details that we talked about in this video. If you have any specific questions, let me know. A best way to contact me is via Twitter. And other than that, thank you so much for your support. Thank you so much for watching, and we'll see you later. Take care.